Hello, how are you, my dear students? Welcome back to our lecture series in General Mathematics. We are now in the lecture series number 8, and our focus will be on the exponential function. But before we are going to start our lecture series, may I introduce again myself? I am Mr. Pajaos, your teacher in General Mathematics. Before we are going to start, please subscribe and click the notification bell so that should there be a future lesson, you will be notified with our updates in this channel. Again, our focus will be the exponential function. But for us to understand the exponential function, there are things or there are prerequisites that we need to go over. Now, what are these? These are the laws of exponents. Okay, the laws of exponent are very much needed in understanding, evaluating, and in the computation of the exponential functions. So the number one law of exponent will be the product law of exponents with the same base, meaning to say an exponential numbers of the same or equal base. Okay, so how is the mathematical formulation of that? We have in here a raised to n multiplied by a raised to m is the same as saying a raised to the sum of the exponent n plus m. So you will notice in here the base are equal. To understand the product law of exponents with the same base, we will be using this sample to elaborate this law of exponent. So you will notice in here that I have 2 raised to the second power multiplied by 2 raised to the third power. Now what did I do? I just copied the base because they have the same base, and I added their exponent, which is 2 plus 5. Now what would be the result? The result will be 2 raised to the fifth power. Now how is that? That is the same as saying 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 to give you a final result of 32. Another law of exponent would be the product law of exponents with the same exponent. Now you will notice this law of exponent is an opposite of the first one. How is that? So you will notice a raised to n multiplied by b raised to n. You notice that they have the same exponent but of different bases. So how do we deal with these exponential numbers? We will just multiply or get the product of the bases. That is the same as saying a multiplied by b. After multiplying this bases, that's the time we're going to raise them to the exponent n. So how do we apply this one? Let's try to continue. So you will notice in here that I have 4 raised to the second power multiplied by 2 raised to the second power. How did I deal with this problem? I got the product of 4 multiplied by 2 to give you 8 and raise it to the second power, which is the common exponent of the 2 exponential number. So how's that? That is the same as 8 multiplied by 8. It will give you 64. Another law of exponent is quotient law of exponents with the same base. To understand this, try to look at this kind of illustration or mathematical illustration. You notice that I have the same base. My bases are A and A. So in here, my result would be A raised to the difference of n minus m. Now I did do this one, n minus m, if the exponent exponent n of the numerator is greater than the exponent m of the denominator. So meaning to say, if I notice that the n is greater than m, I will be doing this one. That is the same as saying a raised to n minus m. So to understand more this one, I have in here 2 raised to 5 over 2 raised to 3. You notice that my exponent in the numerator is greater than the exponent in the denominator. So how would I solve for this one? I would be saying, or copy the base and say 5 minus 3. And so it will give you 2 raised to the second power, which is the same as 4. Another way to understand the quotient law of exponents with the same base, I have in here another illustration, which is a raised to n over a raised to m. You will notice that my condition is the opposite of the first one. What is my condition? My condition is that the n is less than m, or the exponent of the numerator is less than the exponent of the denominator. And so if this is the condition that will prevail, meaning to say we will be doing this pattern 1 over a raised to m minus n. Soon I will be explaining how did we come up with this result. But to understand this, or to apply this exponential law, I have in here 2 raised to the 4th power over 2 raised to the 7th power. You notice that my denominator's exponent is 7, which is greater than 4. So how will I do this one? I would be having 1, constant 1 over 2 raised to 7 minus 4. So I will be having 1 over 2 raised to 3. And so that is the same as saying 1 over 8. Or in the decimal form, that is the same as 0.125. The next one would be quotient law of exponents with the same exponent. They have different base but the same exponent. So I have in here an illustration. So that is the same as we have a raised to n over b raised to n. You notice that they have different bases but they have the same exponent. So how would I do this one? I will be getting the quotient of the bases. And after getting the quotient of the bases, I will raise it to the common exponent, which is n. So to illustrate this one, I have in here 12 raised to 3 over 2 raised to 3. So you have the same exponent but of different bases. So how did I deal with this? I divided 12 divided by 2, which is 6, and raised to the 3rd power, which is the common exponent. And so I will be having in here 216. Next, we have in here power to power law of exponent. How is the power to power law of exponent? So you will notice an exponential number is raised to another exponent. So I have in here an exponential number, a raised to n, but raised to another exponent m. So how would I deal with this one? Now, to deal with this, you just copy the base and multiply their exponents. So I have the result of a raised to n multiplied by m. To understand this laws of exponent, I have in here the quantity 3 raised to 2 raised to another exponent, which is 4. It will give me a result of 3 raised to the product of the exponents 4 multiplied by 2, or 3 raised to 8. And so I will be having a result of 6,561. So try to multiply this one uh, 8 times, and so it will give you this result 6,561. Another law that we need to consider is fractional law of exponent. How is this? In the fractional law of exponent, meaning to say you are given an exponential number. Exponential number, and the exponent is a fraction. So I have in here an illustration, a raised to the quotient of n over m. So how would we deal with this? Meaning to say, if we are dealing with this one, actually that is the same as saying, what is the m root of a raised to m? So the m root of a raised to n. So to understand further, let's consider this illustration. I have in here 9 raised to 3 over 6, meaning my base is 9 and my exponent is somewhat 1/2. Now to simplify this, that is the same as saying, what is the square root of 9 raised to 1? And so what is the square root? That is the same as the square root. What is the square root of 9? And so the square root of 9 is 3. So that is the fractional law of exponents. And now let's continue with our focus for this lecture series, the exponential function. In the exponential function, we have to understand the notation f of x is equal to b raised to x, wherein your b is called to be the base, and x, the exponent, can be any real number. Now you notice that it says in here b must not be equal to 1, but b must be greater than 0. So I repeat, the base, which is represented by the alphabet b, must be greater than 0. Would it be 1/2? Yes, that is greater than 0. Would it be 0.25? Yes, that is greater than 0. But would there be a possibility that your b is equal to 1? No, there is no such exponential function to speak if our b is equal to 1. Would it be 2? Yes, that is greater than 0 and not equal to 1. That is still considered to be the value of your base. So I repeat, in the exponential function, our base, which is represented by the alphabet b, must be greater than 0 but not equal to 1. Now what about the exponent? Our exponent is the variable x. So our focus in here is the variable x. Now your x would be any real number. So the value of x would be any real number. What is the domain of the exponential function? Any real number. So meaning to say, we are talking of the domain, and thus that is the same as saying, what are the possible values of x? They are all numbers. Again, what are the possible values of x? They are any real number. And that is the same as, what is the domain of the exponential function? It is any real number. So b is always positive real number. Why? It says in here b is greater than 0. Another one, it exclude 1 as the value of the b. Another one in here is x would be any real number. What are the domain? Any real number. Okay. To continue, what are the properties of the exponential function? Number 1 would be, the graph of the exponential function will always contain 0.01, meaning the graph of the exponential function will always pass through the y-intercept, which is at 0.01. It says in here, for every possible b, we have b raised to x is greater than 0. Note that this implies that b raised to x will not be 0. Another in here is If your b is greater than 0 but less than 1, then the graph of b raised to x will be decreasing. It moves from left to right. So that is the meaning of if your b is greater than 0 but less than 1, then the graph of b raised to x will decrease as we move from left to right. Another would be if b is greater than 1, then the graph of b raised to x will always increase, meaning it moves from the left to right. Another would be if your b raised to x is equal to b raised to a, then your x is equal to a. So these are the properties of exponential function. We will understand these properties as we move on with our illustrations and computations. Let's continue. Let's continue. What is an exponential equation? When we say exponential equation, it is one in which a variable occurs in the exponent. For example, we have in here 4 raised to 2x plus 1 is equal to 4 raised to 4x minus 2. You notice that both sides of the equation have the same base. Then the exponent on either sides are equal by the property if your b raised to x is equal to b raised to y, then your x must be equal to y, where your b is called to be the base, and x and y are the exponent. To continue solving the problem above, which is equal to 4 raised to 2x plus 1 and 4 raised to 4x minus 2, you notice that the base or the bases are equal. They have the same base of 4. So that if they have the same base of 4, we bring down their exponents as the same as this one. We bring down the exponent of b raised to x and b raised to y, wherein your x must be equal to y. That is the same as in here. Your 2x plus 1 is equal to 4x minus 2. To continue solving this one, we have 1 plus 2 is equal to 4x minus 2x, and thus it will give you 3, which is equal to 2x. To continue solving for the x, your x must be equal to 3 over 2, and that is the exponential equation. Let's continue. The applications of exponential functions, including the laws of exponents. You will notice one of the application of exponential functions are used in the real world to measure the growth, interest, and decay. The growth obey the exponential function. Example of this are the computation or the projection of human population, bacteria, or the chain reaction, and even the compound interest. Another one is decay obeys the exponential function. Why? Because this can be seen in the carbon 14 dating, half-life, or the Newton's law of cooling. Okay, so let's try to see the application of the exponential function in compound interest. Okay, so I do hope you will enjoy this one because we will be talking of the application of exponential function in the computation of money matters. So to compute for the compound interest, we will be making use of this notation. Final amount is equivalent to the product of the principal multiplied by 1 plus r over n raised to n multiplied by t. You notice that we have in here n multiplied by t. That is the same as mode of conversion multiplied by time. You notice this mode of conversion multiplied by time is an exponent, meaning to say this will tell you if the money increases exponentially or not. Okay, so to continue, the P stands for the principal amount. Another one would be the R stands for the rate, and N stands for the number of conversion, meaning to say number of the application of interest in a given year. Next, T stands for time or period, or the length of the interest. Another one would be A is the future value or the final amount. Okay, so that is the working equation for the compound interest. Let's try to see one of the example. So we have in here, if you deposited 9,000 pesos in a 5% interest-bearing savings account that pays an interest compounded semi-annually, how much money would you be in the account at the end of 9 years? Meaning to say, the interest, which is 5%, occurs twice in a year, semi-annually. So that is the meaning of the mode of conversion. So how do we deal with this problem? We will be dissecting the details of the problem. These are called to be the given. Okay, so what is the rate given in the problem? It is 5%. Okay, 5% interest bearing annually. Okay, next, what is the principal amount? We have 9,000 pesos. Another would be, what is the mode of conversion? Meaning to say twice a year, semi-annually. Another one would be how long the savings account stops. Okay, so that is 9 years. And at the end of 9 years, what would be the final amount? So meaning to say, when we are going to solve for this problem, we will be following the equations that I gave to you before. P multiplied by the quantity 1 plus R over n raised to n multiplied by t. So that is the one that we are going to use. You will notice I have in here the principal, I have in here the rate, I have in here the n, which is the mode of conversion, I have in here the time, which is this one. What is the problem? What is the final amount at the end of 9 years? To do the problem, we just replace or substitute this one. So we have in here, that is the principal, which is P. Another would be, what is the rate of interest? 5%, or that is the same as 0.05. And of course, what is the mode of interest? We divide the interest by 2, that is semi-annually. And of course, that is the same as our exponent multiplied by the time. And so to do the problem, as according to the basic of the arithmetic, we do first what is inside the parenthesis. Okay, so what is inside the parenthesis? We have 1 plus 0.05 divided by 2. So we will divide this one, it will give you 0.025. Added with 1, so it will give you, that is the same as 1.025 raised to the exponent, that is the same as 2 multiplied by 9. Okay, and of course multiplied by 9,000 pesos. To continue, again, according to the basic of arithmetic, we have to do first the exponent, the dictate of the exponent. So that is the same as saying 1.025 raised to 18, and so it will give you this value. Now, in the computation of the compound interest, we continue, we have to use we have to get all this decimal number, And when you're thinking of rounding it off, we will round off the final answer, because in here we are talking of money. Okay, so having said that, this result will be multiplied with 9,000 pesos, and it will give you a final amount of 14,036.93. And this is our final amount. I'll give you 10 seconds to at least follow this one with your calculator. Okay. Okay, so that is the final amount, meaning to say the final amount after 9 years would be 14,036 pesos and 93 centavos. Okay. To further understand the compound interest, now let's try to change the problem or have another problem. So we have the same problem in here, but the mode of conversion will be compounded monthly. Now, what do you mean when we say the mode of conversion is compounded monthly? Meaning to say the 5% will be divided by 12, and whatever the result that will be applied monthly. So you deposited 9,000 pesos in a 5% bearing savings account that pays interest compounded monthly. How much money would be in the account at the end of the 9 years? So we have the same problem, only that we change the mode of conversion from semi-annually to compounded monthly. Let's continue. So you will notice we have the same given. So rate is 5%, principal is 9,000 pesos, mode of conversion is 12 times, and the period or the time is 9 years. And so what would be the final amount of 9 years if the mode of conversion is monthly? So again, to solve for the problem, we make use of the uh, working equation for the compounded interest, which is final amount is equal to P, which is the principal multiplied by the sum of 1 plus the quotient of rate divided by the mode of conversion raised to the product of mode of conversion and time. So here is the substitution. So I have in here the final amount is equal to 9,000 pesos multiplied by 1 plus 5% divided by 12. Okay, raised to 12 multiplied by 9. To continue, we have in here the principal. We have in here the rate. We have in here the rate of interest, and then the mode of conversion. At the same time, we use it to be an exponent, and of course the 9 years as the exponent, again multiplied by 12. And of course, how do we deal with the problem? Again, when we will be dealing with a problem, that is the same as we divide the 5% divided by 12, the result would be added to that is the same as 1, so it will give you this amount. Okay, the next one would be, of course, raised to the 9 multiplied by 12, or the mode of conversion, and multiplied by the principal amount. So to do the problem again, the base that we have in here, 1.004167, will be raised to the product of 9 times 12. And so it will give you this decimal number, that is 1.566902823. And this result will be multiplied by uh, principal amount that is the same as 9,000. So the result would be 14,102.13 pesos, and that would be the final amount for uh, 9 years. You notice that when we will be applying the interest compounded monthly as compared to the previous one that is the same as compounded semi-annually, we have more, or the interest earned from this problem, if the problem is compounded monthly, is better than the other one, okay, which is compounded semi-annually. So you think of this problem when you will be planning to lend money, because so if I were you, when I lend money, I will make use of compound interest. And if I would like to have more interest, I would be giving a mode of conversion which is higher than semi-annually. Okay, so let's continue. Again, that is the final amount, 14,100.13 pesos. Okay, so ayan, you notice that the mode of conversion, which is 12, it will bear more interest than the mode of conversion, which is semi-annually. The next topic that we will be looking into is okay, the property of, or the model for the exponential growth. So it says in here, an exponential function models growth whenever its base is greater than 1. Why? If the base is larger than 1, then b is referred to as the growth factor. Meaning to say, when we go back with our previous discussion, now let's try to look at this. When the numbers inside this parenthesis is greater than 1, of course, this is 1 plus point something, so that is the same as saying greater than 1. Again, if the base is greater than 1, meaning let's consider our compound interest inside the parenthesis. Of course, this is greater than 1. This is called to be the growth factor. If that is more than 1, it will always give you it will always give you an exponential increase of what you are trying to compute. I repeat, if this one is more than 1, it will give you an exponential increase. Let's continue. So you will notice, as I'm saying in here, if b is larger than 1, then b is referred to as growth factor. Another would be, we have in here an exponential function models decay whenever the base is greater than 0 or less than 1. Meaning to say, when b is between 0 and 1, then b is considered to be a decay factor. What do we mean by this? If the base is from a number between or located between 0 and 1, the result will always give you a reduction of whatever computation. Meaning to say, it will decay. To understand the exponential growth and decay model, now let's try to make a comparison by having somewhat computation. Okay, so what if I will be having exponential growth by having this model f of x is equal to 3 multiplied by 2 raised to x. You will notice in here that my b or base is 2. Now you notice that my base is larger than 1, which is 2 is greater than 1. Now, what about if we assume an exponent of 4? What would be the result? It will give you that is the same as 3 multiplied by 2 times 2 times 2 times 2, and thus it will give you that is the same as 3 multiplied by 16. What would be the final result? Of course, that is 48. Okay? This 48 in here is somewhat a very big number for this kind of functions. So that is created by 2. As what we have said, it is considered to be a growth factor. Okay, so the result increases exponentially. Okay, what about the graph of this growth factor? You will notice the graph of this exponential growth is from left to right. Okay, uh, left to right in an increasing manner, or left to right in an exponentially increasing manner. Okay, so this is the graph of the exponential growth. Now what about if we consider the other one, exponential decay? Okay, so in our exponential decay, we will consider also this problem. Okay, y is equal to 3 multiplied by 1/2 raised to x. Okay, so you will notice our base in here is 1/2, or shall we say the value of b is 1/2, which is between 0 and 1. Okay, between 0 and 1. Now in here you will notice that when I continue computing, it will give me this one, 3 multiplied by the result of 1/2 multiplied by 1/2 multiplied by 1/2, and another 1/2 is 1/16, which is to be multiplied by 3. It will give you a result of 0.1875. You will notice now that there is the decay of the exponential function, meaning there is a decrease of the computation. There is the reduction of the computation, or shall we say, there is an exponential decrease of the computation. Now, how is the graph of this exponential decay? You will notice that the graph of exponential decay is, we have in here, okay? It is coming from, the left going down to the right, okay, following a curve pattern. Okay, it is coming from left going down to the right, okay, going down to the right, following a curve pattern, again, which is called to be now an exponential decrease. Again, before I will be ending this lecture series number 8, I hope I shared to you ideas about exponential function in my humble capacity. And please click subscribe button and click the notification bell so that you will be reminded of whatever new lesson being posted in this channel. Thank you for listening.